Hello again, Physics 1015 tutorial number 9. So we continue to question 3 now. So in this question, we want to find the Young's modulus of a tendon, okay? So the length of this tendon is 15 centimeters and the extension was found to be 3.7 millimeters by a force of 13.4 newtons. Right, so the diameter again of this tendon was found to be about 8.5 millimeters. So now we want to find or calculate the Young's modulus for this particular tendon. Okay, so let's look at the data that we're given. We have the length of the tendon, which is 15 centimeters. Converted to meters, we have 0.15 meters. The extension of the tendon is given as 3.7 millimeters. Converted to meters, we have 3.7 times 10 to the minus 3 meters. Okay, so the applied force there is 13.4 newtons. The Young's modulus is our unknown, and also the area is obtained by pi r squared, where r is simply the diameter divided by 2. Okay, so now what is the formula for obtaining the Young's modulus? So Young's modulus is obtained by dividing the stress by the strain. So Young's modulus equals stress divided by the strain. So we know also that stress is given as force per unit area, okay, with units of pascals or newtons per square meters. So stress is force over area, where our force is 13.4, and our area there, after calculating, we are going to find the value of 5.67 times 10 to the minus 5 square meters, okay, giving us a stress of 2.4 times 10 to the 4 newton per square meters. Okay, so we have obtained the value of the stress on this tendon. Then now we go ahead and obtain the strain. Okay, so the strain is usually given as the extension divided by the original length. Okay, the extension converted to meters is giving us 3.7 times 10 to the minus 3 divided by the original length, also converted to meters, which is 0.15 meters, and it's going to give us a strain, which is a ratio of about 0.024. Okay, so after having done this, it becomes much easier now to even find the value of the Young's modulus for this particular tendon. Okay, therefore y, or rather Young's modulus, is going to be the stress that we obtained divided by the strain, okay, giving us the Young's modulus for the tendon as 1 times 10 to the power 6 pascals, or newtons per square meters. All right, so this was easy. Then we move ahead, we go to question 4. So question 4 here is just a matter of estimating the area of your eardrum. Nothing special. Okay, so estimate the net force exerted on your eardrum due to the water above when you're swimming at the bottom of a pool that is 5 meters deep. Now the pressure inside the eardrum is atmospheric. Okay, so we want to find the force that is exerted on your eardrum as you swim in a pool that is 5 meters deep. So how do you find this force? Okay, so first, to find the force, and because we're going to be dealing with pressure here at the bottom of that pool, we are going to consider the expression for pressure, which is P equals force over area. Okay, so this one is going to help us obtain the force, but also because this eardrum is 5 meters below the pool, we also need to consider the depth and the density of the liquid as well as the gravity. So also pressure here can be given as rho G times H. Okay, so we can see that F over A is equal to rho GH. Okay, therefore force divided by the area, which is an expression for pressure, is equal to rho GH, which is also an expression for area. Okay, therefore we work out an expression for the force from this. We're going to come up with force equals rho GH times the area. Okay, now this area is the area of your eardrum. Okay, because we want to determine the pressure exerted on this particular eardrum, so we have to work with the surface area of the eardrum. Now, as I said, it's a matter of estimating the value of the surface area of your eardrum. Okay, because we know the density of water, we know G, and we also know the depth H. But what we are not sure of is the surface area of our eardrum. Okay, so just an estimation depending on the value you wish to use. I estimate the area of the eardrum to be roughly about 1.0 times 10 to the minus 4 square meters. Okay, so if we estimate the value of the area to be this, and we also know that the density of water is 1.0 times 10 to the 3 kgs per cubic meters, the depth also is given. Okay, we know the value of G, then we can go ahead and find the value of F. Okay, so we know now that F equals rho, which is the density for water, multiplied by G, multiplied by the depth, which is 5 meters, multiplied by the estimated value of the surface area for the eardrum. Okay, and if we multiply all these values together, we can estimate a force of 5 newtons to be applied on the eardrum. Okay, so here it's just a matter of since we are simply estimating, the force depends on your estimation of the area for the eardrum. Okay, again here, as I wrote, note that A is just approximate for the eardrum.